Let's talk about the 4 types of data. Not all data are created equal. They have different levels of importance and they work in different ways. So it's important to identify the types of data, which are usually 4 main types, to understand how they work within an organization. It would be natural to say that data come in all shapes and sizes. However, different types of data have different nuances and usually different levels of importance. So it's important to clarify both what types of data exist as well as what is the purpose of each. There are usually 4 main types of data in the usual classification, if you will. The first type is transactional data. These are usually long lists of transactions in a business. Probably sales are what come to mind, but they can be orders, receipts, doctor consultations, and so on. They are usually long lists of transactions in high volume, and they are the basis for analytics and reports. The second type are usually master data. These are usually a few selected crucial concepts in an organization: customer, product, location, and so on. These are usually centralized because they're so critical. That is, they're so important that there should only be one source of data for these, period, so that there are no misunderstandings. Out of curiosity, the process of centralizing master data is known as MDM, or Master Data Management. Then, we have reference data. These are codes or indicators that are used by all other data. Think of a list of countries, or a list of phone prefixes, or a product hierarchy, and so on. With a list of countries, for example, any mention to a country in any database table will reference this list of countries. And finally, we have metadata. The strict definition is that they're data about data, which is fair enough, but metadata are so much more than that. They represent information on data types, data models, business uses, data quality validation rules, data owners, assigned data stewards, policies, sensitivity classifications, and a lot more. Their goal is to completely clarify data, especially to people who have no context. Let's start with transactional data. As the name indicates, these data are usually transactions of some type. And naturally, a common misconception is that transactions are sales. And although they do include sales, they may include any other type of transaction which is relevant to the organization. Transactional data are usually intimately tied to how that specific business is run. For example, consultations or even operations can be transactional data for a hospital or health clinic. For a financial institution, it can include product sales, trades in the financial markets, openings and closings of accounts, and so on. They are very unique to the business. The characteristics of transactional data are that they're usually in high volume and they only have meaning from aggregating multiple transactions. In other words, in a convenience store, if you have one record that says that you sold something for $3, that's not going to be critical to the business, but an aggregation of the monthly sales may be. Again, these are not just sales, invoices, or receipts, or bank movements, although they can include these, but they're any element that makes sense to the specific business. As mentioned, consultations in healthcare, account openings and closures in banks, or any other transaction for that business. They're usually not very useful by themselves, but instead when combined to generate reports, dashboards, or other data products. As we just mentioned, a single sale in a region doesn't tell you a lot, but a dashboard of sales by region, by month, will be a lot more significant. Then come master data. These are the data that represent, in specific, essential entities to a business. The most frequent types are customer and sale, or for example, patient in healthcare. They are crucial to business operations. And you may think that all data are important in an organization, so why is there a need to distinguish master data? And the reason is that usually these data are so critical to a business that there must only be one copy of them to avoid inconsistencies. So for example, if you have 10 different customer information repositories, all with conflicting data, then generating unified reports about customers is going to be hell. Not reliable and incredibly confusing. So for less important data, it may not be a problem to have different data sources with different definitions or values. For example, for your social media posts on Facebook or Twitter. Maybe there are different databases with these campaigns and they're in conflict. Yes, this may hurt your marketing a little bit, but unless you're a social marketing firm, there isn't going to be a burning need to centralize the information. But for customers or sales, that's a different thing. So what happens is, if you can centralize everything, you should. But usually, in an organization, that's impossible. So master data are the data that have the highest priority in terms of centralization because they are so critical to the business. In fact, there are entire programs dedicated to just managing master data, which are MDM or Master Data Management Programs. And these usually consist of taking the different data sources for the same entities, then finding a way to merge them, and later maintaining that centralized source of data. Next, we have reference data. And these are data that, as the name says, are referenced by an organization. They're very important because they're very pervasive. In other words, dozens or hundreds of other data sources or applications use these. So what happens is, if you have one single value wrong, for example, in a list of countries, and 71 applications reference it, for example, you immediately cause 71 errors. For example, if you have a product name wrong in a product hierarchy table, and that's referenced by everything, now your website product catalog has a mistake, your online store has a mistake, and any reports about products will have a mistake as well, and so on. Reference data usually includes references and codes for all areas of the organization. Currencies, zip codes for addresses, phone prefix lists, product hierarchies, employee hierarchies, research and development codes, internal department or team codes, and any other codes that may be referenced by the organization. As a general rule, there's no right or wrong way to define the possible values. Just make sure that they're consistent in an organization. For example, take the list of the 50 states of the United States. You can abbreviate them by using the two-letter abbreviation, such as California being CA, or by number, such as California being number 5 in the list. It doesn't matter which one of the two you use, or even another format, just make sure that you always use the same pattern. And finally, we have metadata, or data about data. As you're probably guessing, these give meaning and context to the data, especially when the data themselves are missing important information. They help translate and explain the data. So metadata are usually at the center of data governance and data stewardship. The metadata hub, or metadata repository, of an organization contains all metadata in it. And usually, data can only be properly governed if we have information about them. In many cases, it may even be a prerequisite to trust a data source or to mark it as trusted. For example, you buy a list of commercial leads for sales from a supplier until every single field is documented. What is the format? What does it mean? Who is going to use it? What is the sensitivity of the information? And any data quality issues are documented. And until all of this is in the metadata repository, you may not be able to mark that data source as trusted or not even let it in the organization. This is what happens in an organization with a high level of sophistication. All data are documented and tracked. And if they're not used, period. It's important to notice that metadata are usually split between business and technical, and both are equally important. They're two independent but very relevant dimensions. So business metadata has to do with how the data are used in the business. What are the data uses for them? What is the sensitivity classification? For example, is it personally identifiable information? Is it confidential information? Is it credit card information? Is it patient health information? And so on. Who are the allowed users and teams with permission to view or to manage the data? And so on. All of these are important to generate the security controls and to define permissions later. And that's why metadata are important, by the way. If this information is not present, you have no idea why you can't tell someone that they can access social media data, but not patient health information. Or you may not even know that you have patient health information. Then we have technical metadata. And for technical people, these are the usual data types and specifications. Is this field an integer, a string, and which length, and so on? What is the primary key? Are there foreign keys? What is the database layout? Is it partitioned? Are there masked or encrypted fields? And so on. And naturally, not all databases are relational, so the same applies to other different structures. Please notice that metadata in specific have a close connection to data quality, because remember, they store the information about the data formats, the usual values, and the expectations for any given field, or any database table, or any full database. A simple example is the following. You have a temperature field which should have integer values from 0 to 100 Fahrenheit. You will only know that if the rule is defined. So both the field format and the rule must be documented in metadata, and that's just for starters. Otherwise, you will be looking at temperature values and have no idea what they even mean. Usually, metadata cover 3 key elements which are important for data quality in all related applications, such as identifying issues. The first are the reference data domains. That is, which reference data are used, from where, and what are the specific values. For example, in an address table, if you have a field state with an integer format, you need to state that it's an indicator to the United States state table, which has the format of an integer between 1 and 50, which maps to that list of states by number. Otherwise, it's just a numeric field from 1 to 50. Then, what are the allowed domain values? That is, what are the actual values that the field can take? For integers, you can define the actual values, as we did for the temperature. This field's values must be from 0 to 100. For strings, it may be just the length and patterns. For example, customer first name must be a string with a maximum of 128 characters, and it must be just one token without spaces or special symbols. And then you can also suggest the common value patterns for a field, the usual values that you'll find there. For example, stating that a gender field usually has 3 values, male, female, or custom. Or in the case of the temperature example, while the minimum and maximum are 0 and 100, you can state that the common values may be around 50 or 60. So you are documenting both what data is referenced, what are the accepted values for a field, and what are the usual values and examples. And it's easy to realize how much this makes work easy in terms of data quality. If a data steward suspects there are some wrong values in a field, they just go to that field's metadata and they immediately see, hey, this is the list of values that the field can take, these are the values that it usually takes, and is this a reference or not? And they can immediately detect whether there's a problem or not. If there is no information, that's a whole nother ball game. By the way, usually who fills all of this information in the metadata repository is the data steward that's assigned for that data source. It's important to note here that we can have data quality problems in all types of data, and possibly at more than one level. And naturally, you can guess that problems with master data are the most serious ones, but there are other nuances. For example, let's take a problem with transactional data. That is, you may have a list of 70 purchases, which are all missing the currency field, or are all missing the date of purchase. Every single record by themselves is not a major problem, but the combination can easily compound it. Then, master data. That is, you may have a customer with the wrong address information, which affects all communication with them, mail, shipping address, and possibly other issues. Then, reference data. While master data problems are the most serious, reference data problems are usually the most widespread. So you may have only one product code wrong in your taxonomy, but that will affect product catalogs, transactions referencing the product, your website store interface, and so on. And then metadata. For example, you have no information about which customer data are classified as personally identifiable information, and this is crucial because these require storage with extra precaution and access by specific users or teams, which you will not know, and you may run into a big compliance issue. Now, please note that the categorization of this information of data into these 4 classes is just for convenience. Please notice that they're interrelated and they can have an effect on each other, and they usually do. The classifications are just meant to make understanding easier. For example, all data depend on reference data in some way. So if a currency is wrong, then all transactions are wrong. And master data entities, such as contract, for example, may have wrong data themselves. Then, transactional data in specific usually depends on both reference data and master data. For example, to record the transaction of $130 from company A correctly, you need correct reference information about the dollar currency, which is a piece of reference data, and correct information about the company A customer instance, and possibly reference data within this customer instance, such as a reference to an address or a state or a phone number prefix. Then additionally, all data have their quality improved by metadata because they explain them, and all data, in turn, contribute to metadata quality. So it's a feedback loop. What examples do we have this time? First, master data can be flexible. What I mean is that while master data must cover the quote-unquote key entities in the organization, there are some borderline entities which may be key entities or not. It depends on the interpretation. For example, the entity contract may be transactional or master data, because if a company does simple contracts with one payment, it's almost a transaction by itself. It's transactional data. But if a company does multi-year contracts with several services included and payments and several people assigned, then it's more likely to be a master data entity. Then, data classification is crucial. One of the most important tasks that data stewards perform is to classify data, especially in terms of sensitivity. This is crucial to define privacy and security controls, including access control and permissions. To give you an example, it's going to be very hard to know that you have to protect someone's first name or address in a different way than other characteristics which are not as identifiable if you don't even know which data have which classification. So labeling and classifying is crucial to properly protect sensitive information. And finally, data quality and data stewardship activities provide feedback to each other. Data stewards have an intimate relationship with data quality operations. This is because their metadata help profiling and remediation, for example, and after these projects occur, they usually help refine the metadata information itself. So it's a feedback loop. Then, what are our key takeaways? The first, as we mentioned, is that we have 4 key types of data, and these are crucial for both data management and data governance: transactional, master, reference, and metadata. First, transactional data. These are part of the business. They may be sales, receipts, appointments, invoices, or others. They're usually in large quantities, and they derive insights only when aggregated. Then come master data. These represent the most important entities in an organization: customers, sales, locations, employees. They're usually managed so that they're only in one central source. Then we have reference data. These are codes, indicators, and mappings that are usually referenced by all other types of data possibly. They may be lists of currencies, locations, phone numbers, product hierarchies, or any other that makes sense to be referenced. Then we have metadata. These are data about data, technically, but there's so much more than that. They give context and meaning to data. They are usually either technical, about data formats, technology, field specifications, and so on, and business metadata, which are about the allowed users, the uses and purposes of the data, and the meaning of it. And finally, metadata in specific are closely tied to data quality, and they cover 3 main elements: which data are referenced, which values are actually allowed in a given field, and the usual patterns that you find in that field. So as we see, data quality issues can occur in any of the 4 types of data. Transactional data usually generate insights in large volume. Master data represent the core entities in an organization. Reference data are usually the codes and indicators that are referenced by all other data. And finally, metadata explain all the other types of data.